So here we have an example student record based on the sort of thing that a student administrator might want. So like you said, we've got ID, we've got their first name, second name, contact email address, if it's their home address. Now, look, notice here, so this is a data dictionary entry, so we have this field name is basically the name you would use in your program. Yep. This data type is saying whether it's string or integer. And complex basic means, is it one of the primitive basic data types or is it one of the complex composite ones? Yep. So remember, a composite data type is one we're creating, and the basic primitive ones are the ones that come with the language like string and integer. So I've put student number as string because in Swinburne some of the student numbers have actual characters in it. Do you know what that sort of data type's called when it's numbers with characters mixed in it? Does anyone know what that's called? You can represent it with a string, but it's technically what they call alphanumeric, right? A combination of alpha and numeric characters, yeah. So it's an alphanumeric. It indicates, in other words, it's a code for something, but it's not just digits, yeah? Okay. So it's not something that's meaningful in itself like a name or street. So that's an alphanumeric. And then we've got first name, which is a string, last name, which is a string. Now, email address, you could break it into parts, couldn't you? You could have the username, the domain, etc. But I've just put it as a string for now. But you probably would need at least to do some what they call regular expression processing on that to make sure it's got the @ and maybe a dot. But this other one, home address, so this is not a basic data type. It's not string, it's not int, it's address. And you'll notice underneath it we have date, so we've got date of birth, which is a date. Now we've already used date, right? And date has day, month. This is around the wrong way. It should be century, year, right? But it's got day, month, and then the current year. So it's a complex data type because it has 3 parts. If you remember in one of the tasks, we had to get date dot today dot year, and it would give us just the year part. We could also go dot month, and it would give us the month part, or dot day, and it would give us a day part. Yeah. So we can pull that apart. And so when we represent complex data types, we want to be able to get the different parts out. And this address is the same. We're going to have multiple parts. So last week in the task we did, we just had this as one big long string. Yeah, remember? And you'd pass it around and you'd print it out as one big long string. But it's not easy to say, okay, what suburb was this student in? Yeah, we have to search through the string, find the suburb and pull it out, and it's a bit of work. So really we want to store these things separately. We want to have the street number in one spot, street name in another spot, suburb, state, postcode, country, etc. So we want to have all those different parts represented. So that's going to be a complex data type that we're creating for our program. Date is used across lots of programs, so we saw there's a standard library for that. Address we're going to create just for our program. You could say address is used across lots of programs too, but we're creating it ourselves. We're not going to use a standard library for address in this example. Yeah. Similarly for results. Results is again a complex data type. You're going to have a unit code, mark, grade, semester, year, and maybe multiples of those because you may have done multiple years, multiple semesters. Yeah. So that's another complex data type, and that again is specific just for our application. We're not going to use a library for that. And then we have a unit enrollment, which is like your current enrollment. Again, composite data type with parts, unit code, semester, year. So I think everyone hopefully gets the idea there. The basic data types don't have parts. They're just one big long thing. And complex ones have parts that we want to represent. Okay. So some composite data types are not custom in the sense that we need to create them. And one of those is like what I mentioned. The date data type already exists for Ruby, and we saw that in the standard libraries there. We saw that last week and the week before. But what we're going to do here is we're just going to create a very simple little date class ourselves just to demonstrate how composite data types work. Yeah? So we're going to have 3 fields, day, month, year. They're the 3 parts that we need, the 3 things we're making a composite of. And they're going to be integers. And the examples are, 31, 12, 2001. All right. Because I mean, the other thing is just to have one big long integer, day, month, year, all in one string or in one long integer. But we want to be able to, as I said, we want to be able to get the individual parts. So how do we represent that in Ruby? So in Ruby, what we would do, we're using this keyword class, but I want you in this unit to think about that as being record. Yeah, okay, because that's the way we're going to be using it. So this is defining a record called date. Yeah, and the record has 3 fields: day, month, year. These variables would be available to any functions or procedures that we also put in this class. Let's just jump back. We looked at example of OOP variable scoping. So we had this thing called shared variable that could be accessed within each of these. Yeah. This was just declared here, but you can declare them at the top before you do any functions or procedures. Yeah, and that's what we're doing this week. We're saying these, if there were functions and procedures in here, then these would be shared variables between them. Yeah. So I don't know if I've got the code there. Yeah, I could edit this, and instead of doing, I could take this piece of code here, right, and I can put it in here. And what's a shared variable? It's called shared variable, right? So I could just put shared variable here, right? And that just makes it clear that there is a shared variable in this code. So this, in other words, we're saying this is an attribute of this class, yeah? Okay. If I don't, we can have different sorts of permissions here, but if I took that out, right, the only things that can see this shared variable is this procedure and this procedure, yeah? Only code inside class demo could access that variable, right? Could get the value from it, right? By putting a bit of code at the top, I'm saying, all right, something outside of this class definition, outside of here and here, can now see and put values into these variables. I'll give you an example in a minute. All right. Well, we're not going to have any functions or procedures in here. That's why I say we're treating this as a record. And this is saying, okay, here's the 3 variables or fields we're going to have in the record, which are basically attributes of this class or record. And this is saying who can use them. And basically we're saying anyone can use them. Anyone can read and put values in here. Again, this is just a definition. Yeah. There's no memory created yet. There's no code running yet. So let's say I'm going to go and I'm going to write a piece of code. Yeah. And then I'm going to call it. So first thing I need to do is create one of these things. So I'm going to call it D equals date.new. Okay. And then I'm going to, so that just creates the memory. So we have in memory a day, month and year, but there's nothing in there yet. It's just blank. So we can print that out. Let's go, and then we want to get each part of it. Yep. So the first part was the day. Yep. And I'm going to set that to be, I don't know, say 30. And the next part was the month. And I'm going to set that to be maybe the 5th. And the next part was a year, and I'm going to set that to be 2024. So that is creating memory for these 3 things, and then it's putting 30 in day, 5 in month, and 2024 in year. And the fact that this says accessor means that I can use this dot notation to reach into this date and put values in there. So we've got the 3 parts of this that we've set them, and now we want to print them out. So we can go put s d.day, put s d.month, and put s d.year using composite data types. So let's start to play with this a little bit more. I mean, I've kind of demonstrated this a little bit already. So here's our definition. Here we create memory for it, for one of these, and then we set the day, the month, and the year. And then here we just print it out and format it nicely. If you remember, we use this dollars squiggly brackets, and you can just put the variable straight in there. Do you remember that? And it'll just print it out with these hyphens in between. Yeah. So another way to do that is go put s, date is, just in case, oops, plus date.day. So we're saying go to this thing and get the day component. Yeah. and then we're going to go plus that, and then we're going to go plus date dot month. So we're saying go to this thing and get the month component plus date dot year. So they should be equivalent. Oops. And this needs to be two-string, of course. Sorry. That's why I like this. That's why I like this format, because it automatically converts it for you, and you don't have to worry about the types. Run that again. Oh, still got a problem. Uppercase. See, uppercase and lowercase matters in Ruby. Yep. It did not like that. Yeah. Okay. Okay. So they're equivalent. Those two do the same things. Yeah. But this one's a bit simpler, in my mind. You can do it however you like. Now, the way we've been doing this is when you create one of these things, you've now got to make sure you go through and give them all values. Otherwise, what's going to be in this? Let's just run it. That looks a bit odd, doesn't it? Right? So if I'm not careful and I create one of these things and I don't initialize it, then I'm going to get this weird looking output. So maybe you want to force people to initialize it so they don't forget, right? And if you're going to do that, then you can do this slightly object-oriented thing of having an initialize procedure that takes 3 parameters and puts them in each of these. Yeah. And what this is a special type of procedure that gets called when you create this thing. So if I have this thing called initialize created, and every class can have one of these if you choose to do it this way, but if I have a procedure called initialize, it will let you do a new like this, and you can put in values when you create it. Yeah? So that's going to be different to what we were doing before. Here we had new with nothing in the brackets, and I had to manually afterwards remember to go through and set up each of the fields. Right? This will force you to do it when you create it. So there's no chance you have one of these in existence with just blanks in it like before. Yeah. So this is kind of safer in that you won't have anything that doesn't have any values in it. And I guess it's a little bit quicker to code too, because you don't need, the extra lines of date dot day equals, 31 date dot month. So it'll save you some typing. And date dot year equals 2019. But if you do it this way, then you always have to do it this way. You can't go back to having it like this. It won't like it. Yeah. It'll say wrong number of arguments. If you put an initialize in there, it expects you to always put the 3 things in here. Yeah. 31, 12, 2019. Yeah. Okay. Does that make sense? So it's just 2 different ways of creating it. One, you go through manually and do it. This one forces you to do it when you create it. Doesn't matter which one you use, just be consistent. Now, it could be that you have a composite type within another composite type. Yeah. So if we have a booking like for this room, and what I need to do is I need to have the room number, I need to have the time of the booking, and I need to have the date of the booking. Yep. So the date is one of the fields of a booking. So booking has room, date, time. Yep. And this, of course, is a composite data type, which is going to be one of these, right? Which we just saw. Yep. So in other words, a composite data type can be a field in another composite data type. All right. So here we have our booking. So when we want to create a booking, the first thing we need to do is create the date, and then we create the booking, and we put in the room number, the date that we just created, date type, a date token or instance if you want to use it that way, and then the time of the booking. Which is so this is an example of exactly what you're talking about. They can have different types. This is a string. This is a complex data type, and this is an integer. See, something you can do in Ruby that you can't do in C is you could say, oh, okay, the time really needs to be formatted, or I could just make it a string, and then I could run it, and that'll kind of at least superficially fix the problem, right? But you couldn't do that in C, because C would have said that this isn't a float, right? And it wouldn't let you just change the data type. So that's the difference between static and dynamic typing, which we'll talk about later.